there are laws that govern refraction. Okay, refraction does not occur at random angles. There are specific laws that describe how refraction works. The first two laws of refraction are: first, when a light rays enter a substance perpendicular to the surface of the substance, there is no refraction. Okay, you can see here, right here. If I make the pencil perpendicular to the surface of the water, there is no refraction. Another is that when a light rays enter a new substance obliquely to the surface of the substance, refraction does occur. So it's like bending the pencil like this. So we can see the distortion of the pencil because of the bending of light, or light now passes through the different media. So there is a bending of light in here. Now, the third and fourth law, I will display it here. Okay. Now you will see this bending of light in laws of refraction 3 and 4. Here, when light passes from a lower optical density to a higher optical density, the angle to the normal, we call it angle A, is greater than the angle in water. Okay? That is when the ray of light passes from a substance of lower optical density to a substance of higher density. Now, the A here is called the angle of incidence, whereas the B here is called the angle of refraction. That is law number 3. For law number 4, that is when light passes from a substance of higher optical density to a substance of lower optical density. Okay, see it here. Okay, this is water. Here is a substance of higher optical density, and air is a substance of lower optical density. So, angle C here is called the angle of incidence, while D here is the angle of refraction. So, the angle of refraction here is greater than the angle of incidence. That is, when the ray of light passes from a substance of higher optical density to a substance of lower optical density. The two laws explain the angles to which light is refracted when entering a substance. We'll continue on discussing another property of light, which is called diffraction. Now, diffraction of light is just the bending of light waves around an object. The amount of light diffracted, or which change direction, is dependent on an object's size. This is also applied to light waves that pass through an opening, such as the aperture of the camera or through the pupil of an eye. As light waves pass through the edge of an object or through an opening, light is diffracted or broken into color. Example of this is in here. Okay, you will see that as light passes to a substance, an object, then the light scattered into different kind of colors. That is the example of diffraction. Light wave diffracting through an opening or around an object, the deviation of the direction of light is traveling occurs when the light passes around the edge of an object. The amount of bending which occurs is based on the wavelength of the light or the object size in relation to light's wavelength. In addition to bending, light is sometimes broken into basic components. These components are the colors of the rainbow. You know that colors are composed of red, orange, yellow, green, blue, indigo, and violet. So those are the colors of the rainbow. Red light has the longest wavelength, so that's why you can see it clearly, or it is the prominent color in the rainbow, and appears to be wider than violet light. This is also accounts for a red sky just before sunset or just after sunrise. Now, what happened here, causing a rainbow in our sky? This is because light passes into the droplets of water. So, as it passes through the droplets of water, lights are bended and scattered. Now, the function of diffraction could be, or an example for that is a CD like this. So we have a parallel tiny globes in the polished surface, and this polished surface, and there's a parallel tiny globes here, and this is found in CD. The sharp edges of these globes cause the light to bend and separate the colors of the rainbow. So we can see it if I bend or slant, sometimes we can see the color of the rainbow. This is the parallel or tiny globes that is in the CD. Now, rainbow caused by diffraction or the appearance of a rainbow is the result of the diffraction of light. As sunlight encounters water droplets in the air, the light is broken into colors of the rainbow. This typically occurs just before or after the rain, and the air contains a large amount of water vapor or water droplets. Separation into colors of the rainbow also occurs when the CD is placed at an upper plate angle. These are the effects of diffraction. Do you wonder why stars are twinkling? We remember the song like Twinkle Twinkle Little Star. The stars are twinkling because of the diffraction of light. As light passes from a star, passes through the Earth's atmosphere which is laden with water vapor, the light bends around the water droplets, causing the twinkling effect. Now, there are two misconceptions for diffraction as well as diffraction. We need not to confuse. Okay? Diffraction is just the scattering. Diffraction is just the scattering or the bending of light waves around an object. Whereas the diffraction is the bending of light at its process from differing densities, like for example from air to water. So that is the difference between the two. Thank you very much.